A bit of background before we start. I am building a gear shift and pit speed indicator using a Raspberry Pi, and that's the thing you see in the yogurt pot at the top of this picture. I'll drop a link in here to the earlier video that shows some detail about that project to build this. In this video, what I'm trying to do is check the accuracy and check for any delays in the RPM figure that you see at the bottom of the screen. Let's switch on, put power into the car, and we get the usual flashing thingy there. And one thing, I've changed this so that it shows the closest, it rounds to the closest 50 RPM. And the reason for that is because this aim solo does the same, I think. So let's get that onto the right. Yeah, so you can see that showing the same number. This is all getting a bit, hopefully this will work, because it is a bit, the exposure is a bit dodgy, isn't it? Okay, so let's now start the car. Okay, and I'll blip the throttle. Okay, so now what I'll do is I'll take the video back inside and mess around with it and see if I can calculate any delays in the displays. Let's start by looking at the engine startup at 1/10 normal speed. So I'll slow the video down to 1/10. Okay, they both started at 0 almost immediately. Yeah, there seems to be a slight lag there, doesn't there? Actually, it's not bad. Okay, so bearing in mind this is running at 1/10 normal speed, the lag is very slight. Using my video editor to check the delays, it seems that the delays are ranging between no delay at all, so absolute perfect synchronization, to a worst case of about 0.3 of a second. I suspect some of that could be to do with the way I'm rounding the numbers. I don't know that I'm rounding the RPM number the same way as they are on the AIM Solo. I'm doing a correct decimal rounding. They may be just truncating it to the next lowest 50 RPM, which would make a difference, or the next highest 50 RPM, I guess. Let's look now at what happens when I blip the throttle. It's quite difficult to see it real time because the numbers are changing so quickly. Yeah, that looks as though that's lagging. I'll go and check that back with the video editor. Yeah, but it's not cut and dried because, interestingly, the gear shift indicator number seemed to lead the other one in some circumstances. 5350. Yeah, I don't know why the shift lights aren't showing as coming on at that point, because anything above 4500 should show the shift lights, but I've noticed that when I video this display it doesn't always show in the video, but I can check that to make sure they are coming on. There's no reason they wouldn't, they were working. So and I think in an earlier video when I tried to record this before, I actually saw the green light come on in the video. Okay, so let me just check this now. Yeah, so sometimes the gear shift indicator is leading, and sometimes the solo is leading, so this is not clear cut at all. Actually, this is quite a false test, blipping the throttle like that, because that's not what actually happens to the RPM when you're driving. So let's have a look at a realistic climb of the RPM. Okay, what we're doing here is this is the same software, it's just I'm running it on a PC because it's easier for me to do a screen capture on it. What we're feeding into it here is data from a race that I participated in at Snetterton, and so this is real data being played through the gear shift indicator about at real time. In fact, it should be real time because it's got the same delays in the data feed as you get with the frequency of the feed off of the AIM. So if you notice the engine speed, particularly when you start getting into third and fourth gear, you can see that the engine speed doesn't change rapidly, not the way it does when you blip the throttle. Of course, if I blip the throttle when I'm downshifting, then the numbers will whiz round, but otherwise not. So I think, just trying to think where we are, I think at this point we're coming up to Agostini, which is a left-hander, so it should change down to second. Yeah, okay, so this is going round Agostini. Okay, so now we come out of Agostini and we're going up towards a left-hander called Hamilton. I'm talking you through this because there's a bit where we'll see if the red line indicator works. So I think we've gone through Hamilton there. Now, what you do when you come around Hamilton is you just hold it. There you go. So you just hold it until you hit the red line, and then you turn into the right-hander, which is called Oggies. So two things. The flashing red line indication seems to be working correctly, and also you can see that the numbers don't change anywhere near as quickly as they do obviously when you just blip the throttle. So all things considered, if all we're looking at is a third of a second lag, that's probably good enough. I still think that the display I've got may be a bit of a problem. I have read about people saying that the particular library that I've used to interface with the display, it's called TK Inter or Tkinter, I think they call it, that can be slow, and there may be things I can do to fiddle with that, but you know, definitely as we're only in proof of concept mode here, I don't think I need to get too hung up on the real detail. The main thing is this is usable. I believe it's usable. Okay, next stop the track, and I'll test out my yogurt pot shift indicator. Okay, here we are, just coming out the pit lane at Snetterton. You can't really see it clearly. Oh, there you go. It does improve as we go. It's a bit slippery, the track today, as you'll see in a second. If you watch carefully as we go down here, you'll notice that when I change down, you see just before I've changed down it says fifth. Now we've gone round here and I'm actually in second here, and whoop, a little bit slippery. So it's doing this thing where at low RPM on overrun it's showing the wrong gear. The shift lights are working okay, although I'll come on to that in a second, but the gear indicator is slightly miscalculating which gear I'm in. So I can change that with a configuration file change. I've got a range of values for each gear, and all I've got to do is change the ranges, which isn't easy. I can do it with just a straightforward text editor in the config file. Other than that, it seems to work okay, except for one other problem which I don't think you're going to be able to see. On the top right of the display, it's occasionally coming up with a grey warning saying the voltage is low on the computer. Now I'm using this USB adapter in the cigarette lighter in the car, and although it's quite a high powered one, a high quality one, it doesn't seem that it's good enough for this. So I've got plans in the pipeline to solve that problem, but really I came away from this test session with 3 different observations. Occasionally the calculated gear value was wrong, the rev range was not right, the lights were not lighting up as I wanted them, so I want to shift the light trigger points around, which is again just a config change. And then I've got this low voltage issue, which I'm going to address with my new setup. Now we've seen what it performs like on the track, I thought I'd just show you an update I've made to the software. So this is the original unit that I had in the car. I'm going to show you the new unit that I'm building, but let's show you this one. The main thing here is that it's running a slightly later version of software. I made some changes. In fact, I made a lot of significant changes, but that's not apparent because they're all sort of behind the scenes. Now it's replaying test data. So what you see now is me going round Snetterton in a race. We're just coming up to Agostini here, I can tell you. So we're changing down, going quite slowly. Now let's just move to the next screen. This is the pit speed indicator that you've seen before. It's flashing, obviously, because I'm doing more than 50 kph. But the new screen that I wanted to show you was this one. If I can just get it to change. There we go. Oh, I've gone too far. Let's go again. There we go. Okay, so I added a brake trace. Now, I have to say, just back up a bit. You may be familiar, if you've watched iRacing videos and things like that, you've probably seen green throttle traces and red brake traces on the just above the dashboard on the on iRacing. And the reason I wanted this is because I'm trying to perfect my trail braking. So that one there is quite good. Actually, the braking in here is a bit strange because at this point in the race, I'm actually right up behind a car and I'm trying to stop running into the back of him. So you see me lifting off the throttle occasionally and braking at funny points. But I digress. The whole point is that now we can see the throttle and brake traces. Now, I don't think I'm going to use this in a race or even on a track day, actually. My purpose of putting this on here is for me to be able to practice in my garage, if you like, although I've got to have the car running because I need the servo active, the brake assistance. But I want to practice braking hard quickly and then trail braking smoothly. One thing I've noticed through looking through my AIM solo data, my data logger data, is that there are 2 problems. Often my trail braking is very lumpy, so I come off too much and then I put on more pressure and then I come off again, which is not great. And the other thing I've noticed is that when I'm heel and toeing, the pressure varies on the brake pedal. In fact, I think that might be a heel and toe there. I've lost track of where we are on the track, but I think that's probably me blipping the accelerator, and that you can see that my brake pressure has come off a bit. Or gone on, if you like, where I've blipped the throttle, I've seemed to have pressed the brake a bit harder. My intention for this is just to use it as a training aid. I really don't think I could watch this while I'm driving and try and react to the shape of the curve. So, this idea of me just sitting in the car and practicing, and even practicing toe and heel actually, or heel and toe, that could be quite useful for that as well. Okay, so here's the new device. It's a Raspberry 4B computer, which is the bottom part down here, as opposed to the Raspberry 2 that I was using. And it now has this CAN board pushed onto the what are called the GPIO pins. So that's all been installed. This CAN board is particularly attractive to me because first thing is it's got two CAN interfaces, so you can see I've actually wired it back to back. And what I'm now able to do for test purposes, I can inject CAN messages out of one of the interfaces and then just use those to drive the software on the other. So it's a better simulation of the situation in the car. The other thing is that it's got this connector here, and this allows you to use any voltage between 8 volts and 24 to not only power the CAN adapter, but also power the board, the single board computer, the Pi 4. So what that means is I can simply wire my 12 volt supply from the car into there, and I don't have to worry about this USB thing and about the voltage dropping off and all those things. So I'm hoping that's going to fix that. Now, one thing I've discovered, unfortunately painfully, because I bought another display for this, is that you can't run this board and a display that plugs into the GPIO. In fact, I didn't really want a board, I didn't really want a display that plugged into the GPIO, but I can't find a 3.5 inch display that will connect to the display adapter, which I don't think, oh yeah, you can just about see it just there. This is called a DSI port. So what I've done is I've ordered a 4-inch display, which has got a DSI input. And the DSI input not only handles the display, it handles the touchscreen side of the display, and it handles power. So I can just power the whole thing from this connector here, and that will do the Pi 4, it will do this board, and it will do the display. I think that's enough about this for the moment. One thing I've decided is that I'm going to make the software available to anybody who wants to use it and perhaps wants to build this. But before I do any big announcement about that, there are a couple of things I want to do. I have started to write an instruction page on my website to explain how to build one of these. But also I want to have a more extendable way of defining the CAN messages, so that, you know, we perhaps have a little message, a file for every car, and it's got the definition of the CAN messages in it that you need, and then the software simply reads the correct file. That way we can build up more, more support for more cars, because at the moment this is sort of hard coded for my BMW E87 116i, which is good for everybody in the 116 Trophy series, but not much good for anybody else. Okay, so I hope you found that interesting, and I'll catch you on the next one.